Okay, so we're open up this model from yesterday, Interaction, Diabetes, and Weight, version 2. And the first thing I'd like you to do is to do a save as. Remember, creating versions of your models on a regular basis when you've completed a logical chunk of work is a valuable thing. And for those really interested in best practices, there's a whole set of technologies that Dylan could speak about with great depth of what are called version control systems that will keep versions of your models successively available so that you can very easily just file them away and get back to them later, compare what the difference between them is, comment on them, etc. Okay, so I'd like to call this Interacting Diabetes and Weight version 3. And once again, our model time units will remain most emphatically not seconds, but years. Okay? So I did a save as, and I'm going to say finish here, and it will finish it. Okay. So are we okay with that? Were you able to do that? Okay. So by doing that, we have kind of a checkpoint. We have a model that at each point that is working, we can always go back to it. We can always see, is this weird effect I'm seeing here in that earlier version will give us a clue as to where the problems came in or where certain behavior that's really interesting and exciting came in. It's great for learning, in short. Okay, so here's version 3 of the model. Now, what we're going to do here, ladies and gentlemen, is we're going to put in place some mechanisms atop this model that we've built for reporting. Okay? And this is going to give us some appreciation for how we can compute aggregate quantities from an individual level model, which is really important because often we want to run these models and get insights from them. And one of the ways we get insights is not by looking at each person in turn, although we sometimes will, but by looking at indicators that are common across the model for different subsets of the model. So I'd like to show you how in AnyLogic you can add such indicators, okay? So let's go remind ourselves of this model. Double-click person, and here's our little model that we created yesterday. And it's embryonic. Lots we can do to enhance this, and enhance it we shall here and there. Okay, so ladies and gentlemen, recall we have normal weight and underweight, normal and underweight, overweight and obese on the one hand, and then we have diabetes on the other. This is a sort of separation of concerns between these two state charts, although they do communicate via this diabetes hazard rate. I'm going to put it in between them just to sort of communicate the fact that it links. Sometimes, for sake, this is just this more has to do with the understandability, transparency of these models. Transparency of the model matters. It matters being convincing to people. If you can show them a model that they can understand, they're more likely to feel a sense of understanding and appreciation for it. And if it's the stakeholders involved in the project, they're more likely to feel a sense of ownership or a sense of a stake in it if they can understand it. So I'm going to go down and I'm going to go to the presentation area, and I'm going to actually just note here that sometimes in these models we actually use mechanisms that will actually depict sort of dependencies here. And one of the ways that we can do that is by drawing in this canvas, drawing things actively. And one thing I'm not sure if it will work, but it might well. Dylan, I think you've tried this.
It's lovely when you're trying to, like when you're building the model in the canvas, they show up.
Yeah.
But AnyLogic strips specifically those links out
at runtime when you're running it. So we could put this in here to kind of communicate that this thing depends, that this transition depends on the diabetes hazard rate. And when we run it, that won't be visible here. We won't actually see it. But at least while we're looking at the model, we can see, okay, this one depends there. And if you do that, I would just note, so how did I do that? Let me just rehearse this. So I went here, I went to the palette, I went to the system dynamics area of the palette, and I dragged out a link. And I then connected up this link. I'm not actually changing model functionality now. I'm just adding a bit of illustrative features. By having this link sort of illustrated, I could choose plus on it, and it will indicate as the diabetes hazard rate increases, the tendency of people to go down here, down this transition, the likelihood the hazard rate down this transition will rise. So now I've kind of visually indicated that this variable has something to do with this. I might also provide, does anyone remember from yesterday? It was perhaps a long time away, a long time ago for you folks. Does anyone remember where diabetes hazard rate was changed? Wherein was it changed? Whence did its values come? Anyone remember?
The states.
The states, indeed. Each of these states, we assigned a value to the diabetes hazard rate. So one thing you might consider doing would be to drag in an indication that will just show, okay, visually, the value of this variable depended on that. Now, it's exhibiting truculence of uncertain etiology here. So let me frob it. Yes, Jeff.
Usually it's easier to drag in a little auxiliary variable.
Okay.
Yeah, it doesn't like linking to things that aren't auxiliary or aren't in the SD cover.
Okay.
So make a little point.
Yeah, it's
dynamic variable I usually use, and then
okay. Yeah, it's
and then sort of
yeah, it's true. It could do it with a dynamic variable. The only problem is, yeah, it's okay. It's being very unhappy in its rendition. I think I could bend it to my will, but it's exhibiting distressing truculence. I don't know why this one was able to do it so fine, but
It's
yeah.
because of the links that you're using,
Yeah, okay.
specifically the system dynamic one,
Are meant for
it's meant to show
yeah.
this thing affects this other thing, or it's directly drawn into this other thing.
Yeah.
And so you
Can't connect it
you have
up
to
with a
directly
variable.
draw stuff into a
Yeah.
variable. So really,
Okay.
the easiest way to do this, both from the Canvas point of view and from at runtime, would be to use a line or a polyline or something like
Yeah.
this.
This one here from the presentation palette.
Yeah, exactly. And I kind of want to make the point to everybody who's looking at this and wondering why we're drawing lines here. This is really all part of visual documentation rather than just text documentation.
Right.
You can write a report, you can write a wiki entry or a Word doc and pass that off to other people who are looking at your model. But I mean, people are really highly visual creatures. If you group things together, put a rectangle around them, and put a heading, I mean, it takes you 30 seconds to do that, and it suddenly becomes so much simpler to understand what the pieces do in relation to one another. And it's not just for external stakeholder benefits, it's for your own benefit. Because some of these models can get really large if you want to make them very detailed, if you want to make them heavy duty for a large phenomena. And if things are disorganized or it isn't clear how the parts fit together, it becomes very easy to forget just what affects what and what levers you might have in order to change the behavior of different components of a particular agent.
Yeah. Thank you, Dylan. This is very important, and particularly if we're to think about the community context. If we're to think about building useful models that actually get used, whether it's in an organization, whether it's in the community, if they get trusted, one of the best ways to help make that happen is to make them transparent, make them understandable. Now, I recognize that not all modelers feel like this. I have a very senior colleague, a modeling colleague, and with him I've written manuscripts and whose opinions I trust very much, who's a big advocate of what he calls sort of big science of modeling. He thinks modeling is the sort of thing that it's kind of like astronomy. You can do a little bit as an amateur, but really where it should be done is in big science organizations, large governmental groups. And I respect that opinion. I happen to disagree profoundly with it, but I do respect, and I think it's a coherent viewpoint. It's a very interesting one. And, you know, from his perspective, making the model transparent, he's totally uninterested in it. He wants to deliver black boxes to people that they can push buttons on and run, but which they don't need to know about the details. That's known by technocrats only, who are properly skilled. I couldn't disagree more. I think models are part of a group context, which is very important. And if you have a model that people understand, it's much likely to go further. Much likely to elicit better understanding from people and building it. It's more likely to have its recommendations taken further. So, as Dylan says, spiffing up the model visually. I just added in these lines and I colored them red to indicate they changed this variable. These are just little conventions that you can choose how to represent it. The point is to have a model that when someone looks at it, you can explain it easily and they won't feel put off by it. And these types of visual elements can help in that process. So just think about that. I was just showing how, you know, one way that we can help communicate elements of a model. Okay, and Dylan can talk a lot more about this, and Dylan has some nice layouts for his model. You can also, I would note, color these things. We didn't spend time on it yesterday, but we could color this green and this one red to help communicate to someone that, you know, when they're in this state, they're green, otherwise they're red. It's a visual language you can build up. Okay. Anyway, I would like to get on to some reporting components. So I'm going to actually stop this and